Okay, let's dive into some details about sound analysis. We've kind of played around with Analyze, Chop up to this point, um, but I want to talk a little bit about different types of analysis. This kind of gets into a little bit of like audio engineering, but this is kind of the more conversational level. It's good to be aware of. So, part one, we're going to look at time domain analysis. So when we see this kind of audio waveform, what time domain means is you can imagine a graph, and so on the horizontal axis, the time is passing, right? And then the vertical axis would be the sort of amplitude of that signal. And then later, when we get into frequency domain analysis, this is when we get into, let's say, like an EQ from the DAW, any sort of graph. If you imagine now the horizontal axis is not time, but it is frequency. So lower frequencies on one side, higher frequencies on the other side. And then the same thing, vertical axis would be the sort of amplitude of each of those frequency bands. So we'll look at some chops related to these techniques. And then also looking at tap tempo, which isn't really analyzing the audio signal itself, but it is a way that you can sort of manually tap, 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 and kind of assign the beats per minute, which you can then use for your visuals also. So that's a good kind of improvisational way if you wanted to match up with some sort of DJ or other musician. So let's start with time domain and looking at Analyze Chop. And so let's zoom in here. So we're using the famous banana. And I've got several things happening here. Maybe first, let's do this. Let's go ahead and give it a little play. Okay, so I don't want to play too much to not trigger the automatic copyright flag. To dive into Analyze first, let's look at this. I'm actually using kind of the focus of this is these two right here, really. So let's just do a little. What should they be? Bright green. Let's make them bright red. Okay, cool. And I'll make them a little bit bigger. So we've looked at Analyze. Let's just look at the, by default, the function is average. Before you should look at the operator snippets. So I feel like this is a really nice overview of what Analyze can do. It's not just for sound. It's analyzing any chop data, and it's finding different patterns. It's finding the maximum, the minimum, the sample index of the maximum and minimum. So average is like averaging all these. For judging amplitude of an audio signal, the standard sort of formula is called RMS power, which is root mean squared. It's a certain type of mathematical formula that takes in each of these sample blocks and then gets the amplitude from it. So that's what we're using. This track has two channels. It's a very nicely separated left and right channel. So I'm kind of keeping the left and right channel for now. And so we can see. Oops, don't like this. I'll get a trail so we can see. And so it's nice to get a trail so you can see at a glance what type of values you're dealing with. It's very quiet right now, so it's 0.02, which is very low. So we can see even in these relative peaks, it's not even getting up to 0.1. So with that information, I tend to always use a math sort of after an analyze and use the multiply. So this just functions like a gain, right? So just amplifying that. So it's going to be a lot more. So in a range that we can use, it's more useful for parameters. So this, I think I have going to the banana. Yeah, I have it going into the level here. There we go. So it's just affecting the brightness. So I used the math to kind of do that. So again, like math, I just did the multiply. I could have also done a range, same thing, but I kind of just like thinking about a certain type of gain value, like times 8 right now. So you play around with that to whatever you want. So what's happening with this filter here, though? Let's read audio filter chop. So we looked at this with the EQ in our in Reaper and with other audio programs. So you can use low pass, high pass, band reject filters to shape the sounds. The roll off parameter, which is decibels per octave, controls how steep the cutoff slope is. Higher numbers are steeper. So let's see what I'm actually doing here. So right now the device out is playing the whole file, but let's maybe do this here. Let's run from the filter into the audio output, because I have a band pass right now that is at 600 hertz. So now we can hear. Also, this is a great example. It's like all right channel right now, no left. So this track has really great, interesting spatial separation. So we can hear by moving that around, we get a different little band. You'd be doing this. Let's say if you had a track, there's a bass, there's maybe a hi-hat, different sonic elements that occupy different frequency bands. Like, different sounds tend to all kind of blend together, so it's really hard to really separate it. Yet, if you wanted to separate like a hi-hat away from a kick drum, that would be more easy to do. So one way to do that would be, just hook this up, listen to the output and just kind of play around with these frequencies here until you kind of feel like you can isolate the certain sound that you want. So the idea right now is, I'm isolating this kind of low mid frequency, so only that affects the banana. So not the bass part, not the really high part. Another way that we could do this, I already have Reaper kind of set up here. If you imagine, if you have an audio file for what you want to visualize, a good technique would be load that into a DAW like Reaper, open up an EQ right here, and then you can kind of see, so we have the same type of filters that the audio filter chop has. So this number 1 is a high pass, so we can see visually what it's actually doing. Number 4 is a low pass, so it's allowing low and then cutting off the high. And 2, so let's see, I can do band pass. So that's what we're doing right now with audio filter chop. It's a band pass, which is at 600 hertz, so it looks right about like that. And then also we have band reject, which is typically called a notch, which is that right there. So it'll, whatever frequency it's at, it will eliminate those that sounds. And then also it's a roll off dB per octave. This affects the slope of that cutoff. So if we go back, let's say to this one, so it's similar to this Q value, or here in Reaper it's called bandwidth. The relative steepness of that. So a low roll off would be a more kind of easy, gradual slope. A high roll off would be steeper. Okay, cool. So I had to kind of listen to this, and I thought 600 hertz was just fine. Also, filter resonance. This will also sharpen the point of that filter. Dry wet mix, right? So it's 100% to wet right now. So only the filtered signal gets through. 0 would be just the unfiltered signal, and then if you wanted to kind of mix that in between, whatever. Okay. So for the brightness, if I look over here, I'm only using channel 1. So even though I have 2 channels, like left and right here, I kept that just in case in the future, maybe because there's such nice separation, maybe I want to like do different things. You don't have to, this is perfectly fine. I tend to like to simplify things wherever I can. So if I am only using one channel, I like to kind of you know only have one channel in the chop. So also there might be a situation like in this file we kind of saw at times only the right channel had sound playing, left channel is completely silent, and so in that case the banana is not like not brightening up, it's not getting that brightness value because it's only looking at chan 1. So a way around that, if that becomes a problem, which maybe it's not a problem, whatever. Another little trick we can do here is insert operator, add another math, and we can actually average these channels. So combine channels and then average. So now that's squished down to only one channel. So now if, let's say, if only chan 1 has sound at a time and chan 2 is silent, it's going to average that. So like the one channel that comes out here is going to kind of reflect both of those. So that only really matters with certain types of sound, but it's a good technique to know about. Okay, cool. So maybe that's good for part 1. Okay.